Hey folks, Quilly18 here, and welcome to another episode of our Unity 2D space shooter game, where we blow things up. Oh, I just spotted something. Bullets can shoot each other down. Is that good? Maybe? And you can know why. It's because bullets, the player bullets are on the player layer, and the enemy units are on the enemy layer, which means they can indeed shoot each other. Now, we could very easily change that by going to our tags and layers, and instead of having just player and enemy, we then have a player bullet, player enemy, or a player bullet and an enemy bullet layer. And then you just change your physics settings so that bullets can't intersect with each other, or can't collide with each other. But I don't know, maybe they should be able to shoot each other down. We're going to leave it as is, but it's something to think about. I think I sorted out the issue with the ships staying around longer than they should. Nope, apparently not. I'm still kind of confuzzled. I put in a couple of little tweaks and protections here to try to eliminate some excessive layer switching that was happening before, but it didn't fix the problem. I don't know why. Sometimes I know why. I just figured it out. When the player gets hit, when we get hit, we become invulnerable. We change our layer to the invulnerable layer. When we shoot, our bullets get added to whatever layer we're currently on, which is not correct. Because sometimes we're creating invulnerable bullets, which don't intersect anything, or don't collide against anything. Okay, so what we're going to do is we're going to create an int called bullet layer. And in our start... Oh, it just hit me. We are going to set bullet layer to our current layer. And then we're going to use that. So the layer when we actually start the game, which will be player or will be enemy, it will never become the invulnerable layer. Aha, so good. We're going to do the same thing in enemy shooting, because potentially enemies might toggle layers as the gameplay happens. So we're just going to copy some changes over here. Now you'll notice a lot of duplication between these two scripts. Anytime you're copying and pasting and there's duplication, it's often a good sign that what you should have done is redesign things so that they're both the same. There should be one shooting script or ship shooting script that the enemy AI and the player controller both pass information to. That way it'll avoid a lot of like duplication, things like that. But you know, we're just gonna deal with it. It'll be okay. All right, that should solve that problem. Excellent. Oh, I'm still happy that I made the changes to the damage handler to minimize how many. So that didn't hit just because I missed. How many layer changes happen? I think that's going to be for the best. All right, I think we're probably okay. Okay, so two things we're going to handle here. We're going to handle the ship dying and then respawning. And the other thing we're going to do is make it so that it's obvious when we're invulnerable. Because I like the invulnerable feature. I think it's actually a good one. But it's really stupid that we can't see it right now. And so while this is a little bit extra fluff that I'm hoping to get into for the tutorial, I think it's worth doing. Now, there's a couple of different ways of doing it. We could actually create an actual animation of some kind. But right now, in this tutorial, I'm not doing any 2D animations, okay? Which, like, literally, there's no, animation in the project or anything like that. And I'm going to leave out animations in this one. I'm going to do another tutorial later on that is going to be more reliant on animations, or maybe I'll just do just animations in some other setup. So we're going to leave it kind of bare here. So instead I'm going to do some sort of script-based kind of animation. Basically, I'm just going to toggle the sprite renderer on and off. When we're invulnerable, I'm going to blink the ship like this. Very old school arcade effect. I really like it. So in our damage handler is responsible for keeping track of whether we're invulnerable or not, right? So it sort of makes sense that this might be the thing that also toggles whether, like, we're playing the invulnerability animation, which in this case is just toggling the render on, off, on, off. Now, how quickly do we want to do this? Do we literally want to blink it every frame? Maybe. We'll try it. We might want to put in a timer. But so here, if the invulnerability timer is greater than 0, then what we do is we reduce the invulnerability timer, yada, 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 yada. So what we're going to do, if the invulnerability is greater than 0, then we are going to Okay, we reduce the timer. If it gets to below 0 at this point, we reset our layer, and we're going to need to make sure that our renderer, I think we just get renderer. It might be different. Because it's sprite renderer, renderer might not point that way. Is there a shortcut to sprite renderer? No. So here's what we're going to have to do. We're going to have to cache this. So there we have a component called sprite renderer, or we should. So we're going to call it SR. In our start, we're going to grab SR. Well, hang on. Make it more verbose. Sprite rend. We're going to grab SR. We're going to say get component sprite renderer. If sprite rend is equal to null, then debug.log error. Object GameObject.name has no sprite renderer. There we go. We're going to put a big note. Note! This only gets the renderer on the parent object. In other words, it doesn't work for children, i.e. enemy 01. Here's what I mean. So, our playership object has a sprite render on the actual object itself. For our enemy, we don't have a sprite renderer on the object itself. What we have is a sprite renderer on one of the children. Right? So, we can fix this. If sprite rend equals null, before we freak out, let's try equals, in our transform, we can say get component in children. Sprite renderer. Before we freak out, we're going to try to grab a sprite renderer from our children. And then if it's null, if it's still null, then we'll freak out and just spit out an error and call it done. I believe that this will not dig down. I think this will just be immediate children. So if you have an enemy one and then you had another object and inside of that you had graphics, I don't think this would get it. I think you'd have to manually sort of walk the hierarchy. But we'll check our immediate children to see if we might have a sprite render on it. Now we'll log an error, but we'll keep going. Over here in our update, first thing we're going to do, if our invulnerability timer is less than 0, we're going to make sure that our sprite renderer is turned on. First, we'll make sure that we have one. If sprite renderer is not equal to null, because it's always possible that we won't have one for some reason, then sprite rend enabled equals true. We make sure to turn our graphics back on. Then, if we're not below 0, okay? If we're not turning off our invulnerability, then what we're going to do is, if the sprite renderer is not null, we're going to toggle it back and forth. If it's on, we want to turn it off. If it's off, we want to turn it on. The easiest way to do that is to do this. We're going to invert current state. So this will, every frame, this will toggle on and off, on and off, on and off, on and off, on and off. And as soon as we stop being invulnerable, we'll do this. I'm going to have to go back and add some comments before I upload this. But let's go and find out. Let's let us get hit once. Boom. Yeah, it's very, very fast. But, you know, technically it sort of works. I can give myself some more hit points so we can make it more obvious. Let's go and set our health to 5. Now, is that good? Is it bad? I don't know. Maybe we want to have things flash a little bit more slowly. Float invuln anim timer equals 0. And do something like that, where instead of toggling every frame, only do it if the timer's expired. I'm going to leave it as is, but you probably want to slow down the blink, or in fact, you might want to put in a proper animation. But hey, this will work for now. If we wanted a more cinematic experience, we could lower the frame rate to 30. Oh, PC Master Race. Because right now, if I hit play, it is on VSync, and my monitor has a refresh rate of, I guess, 69 hertz. 69. So that's why that's the frame rate, because VSync is on by default. If I turned off VSync in Unity, it would probably flash so fast you couldn't even see it. So clearly, it's not the correct way to deal with the animation thing, but it'll be good enough. Okay, so now we're dying. Great, that's exactly what we want ish. No, not really. How do we get us to come back to life? Well, we do want to die. How do we get us to come back to life? Should the player have lives? Yes. I think the player ship should have only the 1 hit points. I think any damage at all should kill the player. Okay? No multiple hit points. Maybe we can get shields later on or something. I don't know. But right now, player should die instantly if he takes damage. Let's make the player ship into a prefab. We're going to need that because when we respawn, we're going to need to pop the player back into the game. Let's actually start the game without the player ship in play. And heck, let's start the game without any enemies in play. Let's create, oh, I hate that you can't create an empty object here. Go to game object, create empty. An empty object is an empty object. It's got nothing in it, no graphics. We're going to center it. We're going to call this object player spawn spot. This is where the player will appear at the start of the game. And so we're going to create a script called player spawner. Its entire job will be to cause, whoa, nice typo. Let's remove that component. Let's just delete it and put it back in. Player spawner. Its job will be to create the player at the start of the game, and if the player dies, its job will be to put the player back into play. So here's how we're going to do it. At the start of the game, so we're going to create a public game object, player prefab. At the start of the game, we're going to instantiate the player prefab. If I leave it blank, if I just do this, it'll instantiate at whatever position is the player ship prefab here is set to, which might be fine if we set something in here, but really what we want to do is we want to instantiate it where this spawner is. So we'll say, or where the spawner is, transformed position, and the rotation, we could use the spawner's rotation, or I can say quaternion.identity, which will just be 0 rotation, which will effectively mean that the player is facing straight up, which is fine for us. So we'll do that. But what I want to do is grab a copy of the player. Actually, we're not going to do it this way. I'm going to say transform player instance. And then when this gets spawned, game object, well, hang on. We'll make this a game object. Then we can go player instance equals instantiate. And remember, we have to cast it to a player object because instantiate returns an object, and we want a game object. So at the beginning of the game, we spawn the player. Then every update we check. If player instance is null, which happens when the player dies, then we're going to create a new player. Right away, we've realized, okay, I could take this and copy it here. Copying code is bad. Why don't we go and create a function called spawn player. Now we're talking. I like that. So we'll do this, get rid of this. Start will simply call it spawn player. And the same thing will happen here. Well, we don't want to instantly respawn the player. That sounds pretty boring. Let's have some sort of timer. Float respawn timer equals, say, 3 seconds will feel like too long. 1 second long. So if the player is dead, then respawn timer will go down by time.delta time. And then if the respawn timer is less than or equal to 0, then we will spawn the player. And then it's in the spawn player thing, we'll set the respawn timer time there. Equal to 1. In fact, I won't set it here at all. There we go. Let's see how this feels. So, we've got an empty scene. First of all, we'll just hit play. And we get our error, which we should expect. Why did we get an error? Class. Variable player prefab of player spawner has not been assigned. Right. So, we need to go to our player spawn spot, find our player prefab, and drag that in. Hit play. Now we go. All right, we've successfully spawned. That's step 1. Now, okay, we spawn. Let's drop in an enemy. That's weird. Why doesn't it start turning towards the player? That's weird. Faces enemy or faces player. Should you not? Oh, I know why it is. Aha. See, here's one of the arguments for finding stuff by tag versus player. Right now, the game object, the enemy, is trying to find an object called player ship. Let's see what happens when we play the game we get spawned. We get spawned as player ship clone, which is the default way of doing the name. So how do we resolve that? Well, I could actually use tags, but remember, my player ship is actually untagged right now. If I tagged it to player, and then here I could use find object with tag player. That's one solution, and maybe that's the solution I'll use. The other alternative is in my script that spawns the player. After we instantiate the player, I could set the player name to back to player ship or the player, you know, something like that. I could do anything I want. I'll leave it be like this. We'll search for it by tag. It'll be fine. So this should work once again. Yes, you indeed turn towards me. You kill me. A second later, I respawn while we're having to be colliding, which is kind of funny. The enemy, let's start him a little closer over here to the player. There we go. Now let's move a little before I die. Let's back up. And I'll spawn there, and the player will then, or the enemy will then start turning towards me. I could, again, make the enemy a little bit smarter, make it only shoot when it's actually facing the player, which might feel a little bit more reasonable. Little things like that. We could tune all kinds of different ways. We'll leave it as is. So now we do respawn. We currently respawn an infinite number of times. Maybe we should have lives. We'll do a very, very, very simple GUI over here. So our player spawner, we'll make a public int num lives, which I'm going to set to 4. You're going to say, but 3 is the classic number of lives in the arcade. That is true. We're going to have spawn player take down the number of lives by 1. So, and you spawn the player instantly at the start, so we'll effectively go to 3 right away. And then I'm going to use the old school on GUI system, which is like way, way, way outdated. Well, this will be fine. We'll look at GUI stuff in some future video for some other tutorial. Not in this one. This is the last episode of this tutorial. I want to be clear. So on GUI, we're going to do GUI.label, and then we have to give it a rectangle. So we'll say rect of an x of 0, a y of 0, a width of 100, a height of, I don't know, 50, and with the text of lives plus num lives. That should give us a little text label in the game in the top left corner. There we go, with the number of lives. So if we go here, boop, once we respawn, we lose a life. Maybe we should lose the life instantly. I'm trying to figure out, like, how would you display that? Now, of course, we don't have a game over yet. We instantly died, and then we went to -1, which is kind of funny. So, I mean, the lives is like remaining lives. It's like lives left. Lives left. So eventually we'll go to 0. And then if we have player instance equals this, if num lives equals 0, okay, if the player instance is null, and num lives is greater than 0, then we'll respawn. Otherwise, in the GUI, if num lives is greater than 0, or if the num lives is greater than 0, or the player is at least still alive, it's not equal to null, then we show the number of lives left, which might say 0, which is fine. Else, if we get to this point, the lives is 0 and the player is dead. So instead, we're going to make another GUI label. Game over, man. And we're going to center this on the screen. So for that, I need a little bit of wizardry here. Screen dot width divided by 2 minus 50. Screen dot height divided by 2 minus 25. Width of 100. Height of 50. That should center it. So let's die. Kill me. More enemies. That's the wrong enemy script. We want enemy prefabs. Game over, man. Oh, there we go. So, very simple. Very basic game. I hope people can use this to their imagination to expand it. I totally and absolutely give you the right to use this code as the basis for your own game. The art is, again, I pointed this out in the very first video, the art that's included in this game is technically Creative Commons version like 0. It's totally free. You can use these graphics to do whatever the heck you want. And if you do, that's fine. I do recommend that you credit the author. Again, I'll try to remember to include that in the description down below and tell you where you can find it. It's from Open Game Art. You can find lots of great art assets there. Just give them a note. And heck, if you use my code, it'd be nice if you gave me a note too. Email me. Let me know that because I would love to play your game. And also, it'd be nice if I showed up in the credits somewhere. But you don't have to. I think that's it. I think that's, let me check my list here, but I'm pretty sure, yeah, invulnerability animation, whatever that's worth, enemies that fight back. Oh, we don't have an enemy spawner. I just realized. Hold on. We should do that. Let's do that really quick. We're going to create a new empty. This is going to be the enemy spawner. Enemy spawner. We're going to center this one. This one's going to work a little bit differently, though. We're going to add a component. We're going to call it enemy spawner. And its job, every X seconds, it's going to spawn an enemy. So it's going to start off float enemy rate. I'm going to start off by spawning one maybe every 5 seconds. We're going to give that a test, or a try. Next enemy equals 0. Actually, we'll put a little bit of a delay, 1 second. And then update is going to be like this. Next enemy minus equal time.delta time. If next enemy is less than or equal to 0, then next enemy is equal to enemy rate. And then we're going to spawn an enemy. So obviously we need a public game object enemy prefab. You could make this an array with a lot of different enemy types as well. I'll leave it to an exercise to the viewer. We're going to go to our enemy spawner. We're going to give it the enemy prefab. Done. We are then going to instantiate the enemy prefab. Now, at what position are we going to do this? Well, I want the enemy spawner to be central, but I don't want the enemy to appear right in the middle of the screen. I want it to appear somewhere, kind of a little further away. So what I'm going to do, there's a cool little function called random dot on unit sphere. On unit sphere. This will make basically a random vector where the numbers in the X, Y, and Z can go from -1 to 1 on each one of them. So this will create a random one of those. So we're going to go vector 3 offset equals that. Now, right away we know that in our offset we want the Z to be equal to 0. That's very important. Then we want to make sure it's a certain distance away. So we'll do something like float spawn distance. We'll set it something like 20. We'll try that at first. Then we say offset dot magnitude. Can we set? No, it's only a get. Dot normalize. Hang on. I set offset to be equal to the offset dot normalized version times the spawn distance. So what this will do is this will give us a random sphere. We're going to set the Z component to 0. Then we're going to renormalize it. So the X and Y direction will be normalized to a length of 1. We're going to multiply that by the distance away that we want the enemies to spawn, which should spawn them outside the screen. We're going to instantiate the enemy at, we'll use our spawner's position, although the spawner should be centralized. We're going to add the offset. We're going to give it a random dot, no. The identity rotation is going to be fine, even though technically it's going to cause things to be a little bit wacky. We could also, cause the to spawn pointing with the player. This will be fine. Yeah. So we'll do that. And then the other thing I'm going to do is the spawn rate. We're going to cause it to shrink over time. I'm going to lose 10%. This is probably a little too much. but they're going to spawn faster and faster and faster. Let's see how this feels. Let's zoom out a fair bit on the scene view. There we go. Enemies are coming in from the side. We're like, whoa, we're being shot at. That's the other thing. Like, maybe we should only shoot if we're within a certain range. Even if we don't do forward, it should shoot only if we're in a certain range. Okay, let's find the enemy shooting. The enemy shooting behavior here. We want to know that we're in a certain range. So we have a player target. Okay, enemy shooting. God, this video is not supposed to go on this long. We're going to copy some of this player tracking. From the faces player, we're going to move it over into enemy shooting. So, play the transform for the player. If, in our update, we're going to try to grab a copy of the player to see if we can find the player. Then, in our cooldown, we only shoot if our cooldown is less than or equal to 0, and we have a player, and player not equals null, and vector3.distance. The distance between us and the player, which is, say, our transform.position and the player.position, is less than, say, 3, which is probably a good number. Because we know the height of our game is from the middle to the top is 5. So this will ensure they're within the screen. Maybe we'll do like we'll do a 4. So they're going to be on screen before they start shooting at us. There we go. They spawn. Now there's a bit of a problem where they do spawn like facing up. So sometimes like here they're forced to do a 360. Oh, and I wasn't paying attention to the game view. Let's see how long we can survive. Play testing. That's the thing I forgot. They're going to wander around, be like, no enemies yet. We should probably have the enemy spawn a little bit closer, actually, because that felt like it took a really long time for them to get there. And wow, this is maybe a little harder than I thought. They turn, and yeah, they could like start shooting right away. I was like, oh no, I died. Okay. There's no score either. Does that feel like a shortfall to anyone else? I will leave that to an exercise to you guys to add some sort of score tracking over here. And there you have it. It's hard, but it does start off slow. But the spawn rate will continue to increase over time. Because every time one spawns, it takes 10% less time for the next one to show up. That doesn't mean that it's going to be instant after 10 things, because it's the first time it'll take away 0.5 of a second, the next time it'll take away 0.45 of a second, and so on and so forth. It will eventually get ridiculously short, and already they're spawning very, very, very quickly. Yeah, we may want to put a minimum on that. There's almost no doubt. If enemy rate is less than 2 seconds, enemy rate is equal to 2. We'll set a minimum spawn rate of that, but we'll shrink the distance a bit. We'll make them spawn within, say something like 12 units. That even on a really wide screen, they're not likely to spawn outside of that. And of course, we could do other things. We could have the spawn spots. We could have multiple spawn spots that are literally placed explicitly outside the screen, or we could check the screen boundaries, all kinds of things. Okay, I'm officially going to go ahead and wrap this up. Thank you very much for watching this series. I hope you find it useful in your future Unity endeavors. And of course, if you do make a game based on this stuff, let me know. I'm curious. I want to see. Bye-bye.